This is the video for section 6.1 notes, slides 12 through 14. All right, so an object is thrown vertically at sea level on Earth. The acceleration due to gravity is negative 32 feet per second squared. Okay, now remember that is a constant, right, near the surface of the Earth. So we're going to use this number every time we're talking about projectile motion on the surface of the Earth. All right. All right, but now it says V of 0 equals V sub 0. So this is just a general thing to represent the initial velocity, right, when time is 0. And S of 0 is S sub 0. So same thing, this just represents the initial position when t is 0. Find the height of the object t seconds after it's thrown. So we're trying to look for the S of t equation. All right. So first of all, we start off with A. Now, we remember that A is actually just the derivative of V, right? So dV dt. All right, so dV dt is negative 32 feet per second squared. All right, so now what we're going to do is we're going to separate the variables. So we're going to get that dV is equal to negative 32 dt. All right, now as soon as we separate the variables, then we are ready to integrate. All right, so what is the integral of dV? So remember, the integral of the derivative of velocity is just velocity. Now remember, we would add the c in, but we usually are just going to add it in only on one side of the equation. All right, then what is the integral of negative 32 with respect to t? Well, that would be negative 32 t plus c, right? All right, so now this is v. Okay, so then the next thing we need to do is recognize that we are given that v of 0 equals v sub 0. So that means that t is 0 and v is v of 0, or sorry, v sub 0. So v sub 0 equals negative 32 times t equals 0 plus c. Right now, c would then equal v sub 0, right? Now, it's important to remember we're going to integrate twice, and so we're going to have two different c's, right? So I'm just going to call this c sub 1, right? Because then when we integrate again, we can call it c sub 2, and so we can distinguish between those two different values of c. All right, so now that means that our velocity equation is negative 32t plus v sub 0. All right, now the next thing we do is we want to recognize that velocity is really just the derivative of position. So ds dt. So ds dt is negative 32t plus v sub 0. All right, and so now we're going to separate the variables. So I get that ds is equal to negative 32t plus v sub 0, and then times dt. So now once we've separated the variables, we are ready to integrate. So we integrate both sides. So the integral of ds, well, the integral of the derivative of position is position. So s equals, and then remember we're going to add in c, and we'll call it c sub 2 because we already had a c sub 1. All right, so now integral of negative 32t, so that would be negative 32t squared over 2, right? And then, of course, we can simplify that to be negative 16 plus v sub 0. Now, remember, v sub 0 is a constant, unspecified, but it's a constant. So we get v sub 0 t. All right. And so now we want to use the fact that S of 0 equals S sub 0. So S sub 0 equals negative 16 times 0 squared plus V sub 0 times 0 plus C sub 2. So we get that S sub 0 is equal to C sub 2, right? Because these are 0. All right. And so that means that the S function, so I'll call it S of t, is equal to negative 16t squared plus v sub 0 t plus s sub 0. All right. So now this equation is the height of the object t seconds after it is thrown. All right. Now, this is always going to be usable, right? It does not matter, okay, what situation we're dealing with, as long as we're on the surface of the Earth and near sea level, right? Now, this works for all of our projectile motion questions in this class. So you don't need to redo this. So there's a few problems in the homework. You just can use this. You don't need to redo it because it's going to be the same every single time when we're dealing with feet per second squared as our acceleration. Now, what if we were like in our physics class and we were dealing with meters per second squared, right? Then you might recognize this equation, right, as our S of t equation. that is half of negative 9.8, right? So negative 4.9 t squared plus v sub 0 t plus s sub 0. Now, you might also recognize this. Anytime we have a constant acceleration, our position equation is going to be in the form of uh, 1/2 a t squared plus v sub 0 t plus s sub 0, right? Where a is, this is only for constant acceleration, and that's what gravity is, right? So half of at squared plus initial velocity times time plus initial position, right? So you may recognize that equation, but any projectile motion on the surface of the Earth, we're going to use this S of t equation equals negative 16 t squared plus v sub 0 t plus s sub 0. All right, so that is slide 12. All right, so now we're going to use that equation to answer these questions, right? Use the result from the previous example to answer the questions. From a height of 96 feet, an object is thrown upward with a velocity of 80 feet per second. So what does that mean? Well, okay, for part A, that's the S of t equation, all right? So we have negative 16t squared plus v sub 0, so initial velocity, so that would be 80. And remember, it is positive because we're going upwards. Now, if it was downwards, it would be negative. And then plus the initial position, a height of 96 feet. So that's part A. That's it. Find the maximum height reached by the object. All right, so remember, maximum height, this goes back to like unit 4, right? Maximum height occurs when what is true? Well, remember, if you're thinking about the parabolic motion of this, right, this represents the position. So that's going to be when velocity changes from positive to negative. So we need to know velocity. So v of t equals, so that'd be negative 32t plus 80. And so when velocity equals 0, right, is when it can change signs from positive to negative. So we're going to set negative 32t plus 80 equal to 0. So I subtract 80, and then I have negative 32t equals negative 80. So I get t equals 80 32ths, right? Which of course is divisible. They're both divisible by 8, right? So this would be 10 fourths, and those are divisible, so 5 halves. So t equals 5 halves. Now that's not the answer because it says find the maximum height. So how do we find the maximum height? Well, we're trying to find s of 5 halves, right? And so now I have negative 16 times 5 halves squared plus 80 times 5 halves plus 96. All right, so 5 halves squared is 25 fourths. So I have negative 16 times 25 fourths plus 80 times 5 halves plus 96. All right, so 16 and 4 reduce. So that's going to be 4 times 25. So that's going to be negative 100 plus 80 halves, that reduces to be 40 times 5 is 200 plus 96. So 100 plus 96, so 196 feet. So that would be the maximum height of the object. Now, one thing that I didn't do is I didn't show a sign analysis. Technically, we should show a sign analysis, but we know that the context of the problem, right? If the velocity is is 0 at 5 halves, to the left of it, a number like 0, you're going to get negative 32 times 0 plus 80. Obviously, that's going to be positive, and to the right would be negative, right? And so, of course, you do get that maximum, all right? But that was partially because we knew the context of the problem. All right, when does the object hit the ground? Well, what does hit the ground mean? It means that the position is 0. So S of t equals 0. And so we set S of t equal to 0. So that would mean negative 16t squared plus 80t plus 96. All right, and so now we set this equal to 0. So first thing that I would do is I would factor out the negative 16. So I have t squared plus 80 divided by 16 is, sorry, that should be a minus 5t, and then a minus 6. All right, and so now I can factor. And so I can divide by negative 16, so that makes that value irrelevant. And so this factors into t minus 6t plus 1. And so t equals 6 or negative 1. Now, obviously, negative 1 doesn't make sense in this context because it says it was thrown from this height of 96. So there's nothing before it was thrown. And so it would, when does the object hit the ground? after 6 seconds have elapsed. All right. So that is slide number 13. All right. And moving on to slide number 14. All right. Solve the differential equation. F double prime of x equals 5 cosine x plus 2 sine x if f of 0 equals 3 and f prime of 0 equals 4. All right. So this is a standard double differential equation. All right. So we're given that f double prime of x is equal to that. So first thing we recognize is that f double prime is the derivative of f prime. Right? So df prime of x dx is equal to 5 cosine x plus 2 sine x. All right, so first step is to separate the variables. Now remember, f prime of x is a variable, right? It's kind of like y, right? So we have like dy dx, and so we're going to separate and we're going to get df prime of x equals, and then this whole thing 5 cosine x plus 2 sine x dx. All right, so now once I separate the variables, I'm ready to integrate. All right, so the integral of df of x, or f prime of x, that would just be f prime of x, right? The integral of the derivative of f prime is f prime. All right, now here I have 5 cosine, so 5 times the derivative, sorry, not the derivative, the integral of cosine. What's the integral of cosine? That would be negative sine of x. All right. And then plus the integral of 2 sine. So the integral of 2 sine is 2 cosine x. I'm sorry that the integral of cosine should be sine, right? Because the derivative of sine, so 5 times sine, that would be 5 times cosine, right? And the integral of 2 sine would be negative 2 cosine, right? I apologize for that. And then plus, and I'm going to label it as c sub 1. All right, so now I have that f prime of x is positive 5 sine x minus 2 cosine x plus c sub 1. All right, so now I want to use the fact that f prime of 0 equals 4. So that means that 4 is equal to negative 5 times, not negative 5, sorry, positive 5 times the sine of 0 minus 2 times the cosine of 0 plus c sub 1. All right, so 4 equals, sine of 0 is 0, so this is 0 minus 2 times the cosine of 0. Cosine of 0 is 1, so I get my 0 minus 2 plus c sub 1. So now I can add 2 to both sides, and I can get that c sub 1 is equal to 6. So that means that f prime of x is equal to 5 sine of x minus 2 cosine of x, and then plus 6. All right, so that's f prime. So now we want to recognize that f prime is actually just the derivative of f. So df of x dx, right? And so I have 5 sine of x minus 2 cosine x plus 6. And so now I'm going to multiply by dx to separate the variables. So I have df of x equals 5 sine of x minus 2 cosine of x plus 6 dx. All right, so now once I separate the variables, I'm ready to integrate. So on the left, the integral of the derivative of f of x is f of x equals integral of 5 sine x. So 5 times cosine. Now, or sorry, remember the integral of sine is negative cosine of x. All right, and then minus 2 times the integral of cosine, which is just sine of x, plus the integral of 6, which is 6x, and then plus c sub 2, right? Not to confuse it with the c sub 1 over here. All right, so now I'm going to use the fact that f of 0 is equal to 3. So 3 is equal to negative 5 times the cosine of 0 minus 2 times the sine of 0 plus 6 times 0 plus c sub 2. All right, so now I've got cosine 0, sine 0. All right, so negative 5 times cosine of 0. Cosine of 0 is 1, so I have negative 5, minus 2 times the sine of 0. Sine of 0 is 0, and then plus 6 times 0, that's 0, plus c sub 2. So now I'm going to add 5 to both sides, and I get that c sub 2 is 8. So now the f of x is equal to negative 5 cosine of x minus 2 sine of x plus 6x plus 8. And so that is the solution to the differential equation. And that